This is one of the two heat sinks. 2-inch, it was sold as 2-inch by 2-inch square. And this is a 50 millimeter square fan. And these are 10 millimeter standoffs. I thought I could get by with shorter ones, but I didn't have any shorter ones. This is the hole that's going to secure this device. It's drilled somewhat off center because I wanted to drill in between the fins. And on dead center is right into a fin. So consequently, I've drilled it a little bit off center. Probably mount the device something like that. This is a mica insulator. It was included in the kit. There was a screw supplied with the kit. It's a lot longer than it need be. I mean, it's almost ridiculously long. Now, you can use an M3 metric or you can use a 440 imperial screw. I drilled and tapped this hole for an M3. My recommendation is when using any kind of an insulating pad, and it could be a flexible silicone pad or one of these mica pads, you apply heat sink compound to both sides. Now the side that goes down, you can just put it on the pad itself. You see it'll squeeze out nicely. On the device, I recommend putting it on the device. And it does not require much. Once these devices are mounted on the heatsink, it might be nice to check to make sure that the device is in fact insulated from the heatsink. Now this screw will not be insulated, but this, and of course any one of the terminals, needs to be insulated. So this is looking at the rear. I don't have the fuse holder in it. Looking at the rear of the soon to be, I hope, power supply. Let's look down at it. These are little tie wraps. I just tried to do some wire management. And I don't think I needed these holes, but I really wanted to try these hole saws out. I bought a 10-piece set, I think, from half this size, double this size. Now, to be fair, I did use these on a variable speed drill press, so I was able to slow it down. Made very nice holes. Discoloration is due to the fact I sprayed brake cleaner on it in an attempt to get the double-sided tape off. And here it is mounted into the back of the case. I did check the polarity. These are the correct polarity when I plug them into the fan supply. And I need to begin doing the power wiring, which includes coming up here to the front which includes bringing a hot wire up to this switch and back to wherever I decide to join it to the transformer wiring. Then I'll try to neaten everything up and proceed on to the front panel wiring. I'm going to install this back, I hope for the last time. This is the neutral connection to the IEC connector. The ground wires, of course, to the ground terminal. And this is the line input, but it's shunted down by this metal bar. Goes through a fuse on the far side, and this is power. This is the hot wire, so to speak. And all I did was ran this red wire up to the switch on the front panel. The two remaining transformers I connected to another red wire that goes to the front panel switch. These are the fan connections. And the color of these wires is meaningless. I just happened to pick up those colored wires. Lots of heat shrink. And not much else to say. Now, I do not have the pass transistors hooked up yet. But I think I'll plug it in and see what happens. Well, no smoke yet. Now I need to move on to the front panel. This depicts those little Chinese combination volt ammeters. They come in, that I know of, 3 different sizes. They have some heavy wires. And these are used to measure current. And you do indeed wire, in both cases, the heavy black wire to the negative output of your power supply, and the heavy red wire to the negative side of the power output. The positive side is wired to the positive output with wire of your choice. The thin yellow, or sometimes it's white, wire measures the voltage between the output of the power supply and ground internally. The thin red wire carries positive voltage to power the meter. So they're both hooked to the positive output. The difference is, in this situation, the meter itself is powered by the device providing the power. In this case, this via this. The caveat is that at least most of them are limited to operation between 4 and 30 volts. 30 volts you tend or might damage the meter. Less than 4 volt, the meter won't work. Now, power will still flow. There'll be output voltage in the supply. It's just that the meter itself dies. If you raise the voltage above 4 volts, it comes back to life. The other option is to have the meter powered independently, in which case the thin red wire, instead of going to the power supply, goes to an independent source. And while in this configuration the thin black wire is not used, in the independent power supply, the thin black wire goes to an independent power supply. I've been asked this question many times. It's fairly intuitive until you run into running the red wire to the negative output. I don't have much room inside this power supply for two independent sources. So I'm going to start with it wired like this. And I hope it does not make more than 30 volts. Now this document, as well as a lot of other documents pertaining to this supply, will be uploaded to my subdirectory, noted at the bottom in the description of the video. Some of them, like this one, I may upload tonight, because this is not going to change. The bill of material might not change. The board layout won't change. I might as well upload the templates, so I'm happy with them. Well, the board layout may change because I may take some test voltage readings at various places, incorporate them onto the schematic and onto the component layout. So if you guys are having any trouble, you can at least probe around with a meter and see at what point your readings are off. So now I'll proceed to hook up the output. So here is the completed 30 volt tube. Well, that's a hell of a note. I'll have to change my templates. It's a 30 volt 1 amp supply. That's why I don't want to put the templates up until we're all done with this. I've got this one hooked to a dummy load, which is currently drawing almost 1 amp, which it says. And watch what happens when I turn down the voltage. See? The meter doesn't read until it gets up around 4 volts. Which is to be expected. That's what it says here. More than 4 volts. I've got this power supply in the short position in order to set the current. Well, I can't because, so I'll do it to this one. I'll increase the voltage a little bit. Watch what happens when I go to set the current. I can't. However, let's see what we can get maximum. It's 24 volts with 1 amp load. no load goes to 31 volts. Now at 31 volts, the integrated circuits are operating 5 volts or 6 volts over their maximum allowed value. So I'll probably change the template to read "24-volt, 1 amp power supply." The 10-turn pots make this very easily adjustable. See if we can hit 20 volts. See how well regulated it is? Not bad. I'll revisit this once I get some independent meter power supplies. But it's pretty tight in that case, so I'm going to have to really squeeze. So we haven't heard the end of this yet.